Hello everyone. Today we'll learn about the remainder theorem together. Normally, if we want to find the remainder, we will calculate it vertically, like this one. If we want to divide 8 by 3, we can find that the remainder is 2. If we want to divide x squared plus 1 by x, we can find that the remainder is 1. Although the results can be calculated, the process is often complex and prone to errors. So today, we are going to learn the remainder theorem, which can quickly help us find the remainder. It's an excellent way to find remainder. Okay, firstly, let's take a look at its definition. Remainder theorem. When the polynomial f(x) is divided by polynomial ax minus b, where a is not equal to 0, the remainder is f b over a. But why is it equal to this value? Let's prove it together. If f(x) is divided by the polynomial ax minus b, where a is not equal to 0, let qx is the quotient and rx is the remainder. Since the degree of ax minus b is 1, the degree of the remainder is definitely lower than the divisor, because if the degree of rx is greater or equal to the divisor, like this one, if the degree of rx is greater than ax minus b, it can continue to divide, right? So if rx is the remainder, so the degree of rx is lower than 1, so the rx is a constant. We can write rx equals to c. So fx can be written as ax minus b times qx plus c, because c is a constant. So c equals to fx minus ax minus b times qx. Obviously, we can make this equals to 0. And this time, x is equals to b over a. Because in some cases, we don't know what the qx is. So we can make ax minus b to 0. We know 0 times everything equals to 0, right? So we can make x equals to b over a. And we can find that c equals to f b over a. And this is the proof process of this theorem. Okay, after discussing the theoretical knowledge, let's practice a few questions to familiarize ourselves with this theorem. Okay, let's see the question 1. Find the remainder when fx equals to 4x sub 6 minus 3x sub 3 plus 2 squared. 2x squared minus 7 is divided by 2x plus 3. Okay, we can find that 2x plus 3 is a form of ax minus b, right? So we can find that a is equals to 2 and b is equals to minus 3. Okay, then we can use the remainder theorem. In this case, so the remainder is f b over a is equals to minus 3 over 2. Okay, let's calculate it together. Right? Okay. Let's find out the result. It equals to 929 over 64. Okay. This problem can be solved quickly, right? Now, let's move on to the next question. We can see question 2. When 2x sub 3 plus 3x squared plus kx minus 6 is divided by x plus 1, and the remainder is 7. Okay, we can, it's not difficult to find that the x plus 1 is still a form of ax minus b, right? Okay, so in this case, a is equals to 1 and b is equals to minus 1. We can take it into the polynomial. So 2x squared 2 sub 3 plus 3x squared plus kx minus 6, we can let it to px. Okay, so the remainder is p minus b over a, right? Let's calculate. So it equals to p minus 1 it equals to 7 because the remainder is 7, right? So we can find out k equals to 12. Oh, minus 12, sorry. Okay, let's practice. Let's continue to practice. Let's see the question 3. The polynomial x sub 3 plus ax squared plus bx plus 6, where a and b are constants, is denoted by px. It is given that x minus 2 is a factor of px, so the remainder is 0. And that when px is divided by x minus 1, the remainder is 4. Find the value a and b. Okay, we can find that x minus 2, x minus 1 are all the forms of ax minus b, right? But in the same question, it's best to use different letters to represent different numbers. So we can write it x minus 2 is a form of ax minus b. X minus 1 is also a form of cx minus d. Okay. So in this case, in case 1, p minus b over a is equals to p minus 2, because in this case, a is equals to 1 and b equals to 2. So it equals to, it equals to 2. So we can find this equation. But in fact, we have 2 unknowns. We want to figure out what's the values of a and b. We need 2 equations, right? So we need to find another equation. In case 2, x minus 1 is a form of cx minus d. So c is equals to 1 and d is equals to 1. So p1 is equals to 1 plus a plus b plus 6 is equals to 4 because the remainder is 4. So we get another equation. We have two unknowns, two equations, so we can figure out what's the value of a and b, right? So after calculating, we find that a is equals to minus 4 and b is equals to 1. And this is the answer. It's very quickly. Okay, let's see the question 4. It's the last question. Slightly increasing the difficulty, we can make it a try. In this case, fx is equals to x sub 4 plus ax sub 3 plus bx squared plus 3x plus 9 is divisible by x plus 1. So the remainder is 0 because it's a factor, but leaves a remainder of minus 33 when it is divided by x plus 2. So this is case 2. We find that the condition have two unknowns, right? So we need to find two equations again. In case 1, x plus 1 is a form of ax minus b. So a is equals to 1 and b is equals to minus 1. So f minus b over a is equals to f minus 1 equals to 1 minus a plus b minus 3 plus 9 equals to 0. So a minus b equals to 7. This is the first equation. Then we need to find another. We know x plus 2 is also a form of cx minus d. So c equals to 1 and d equals to minus 2. In this case, equals to f minus 2 equals to 16 minus a times a plus 4b minus 6 plus 9 equals to minus 37. So in this case, we can get 2a minus b equals to 14. We have two equations, two unknowns, so we can get that a is equals to 7 and b equals to 0. So fx equals to x sub 4 minus plus 7x sub 3 plus 3x plus 9. So if fx is divided by x plus 3, it's still a form of we can use the remainder theorem again. Okay, x plus 3 is a form of nx minus n. So m is 1 and n is minus 3. So f n over m is f minus 3 equals to minus 108. This is the right answer. Okay, let's make a summary. Now, I believe our students have already have a clear understanding of the remainder theorem. With the remainder theorem, in some cases, we can quickly and accurately calculate the remainder. Okay, that's all for our class. Thanks for listening.